Okay, let's start. Good afternoon, everyone. Nice to have you here. I had a session in the morning focusing. How many of you attended the morning session? So, okay, I would repeat some bits, but I'll try to dive a little bit as the session suggests. They're not that, yeah, I think it can make it even interactive. There is a microphone over here, so if you have questions, I hope we'd have enough time to cover it, so don't hesitate to interrupt me. Not too much though, so just keep it. So my name is Christian Tzolov. I'm part of the Spring team at Broadcom, and I'm co-lead for the Spring AI project and founder and lead for this new Model Context Protocol Java SDK project, which those are very interrelated. Today, we're going to talk about how you can build your AI applications, how Spring AI can help you with this, how you can extend this into this new paradigm for agentic systems, how MCP or Model Context Protocol help you to unify the access to external resources and build those agents. And I'll try to cover various aspects. I rarely have the opportunity to dive deep into, for example, we're going to talk a little bit about multimodality, some nice examples there, funny bits, usually it's content that I'm skipping. I'm going to touch about observability, a subject that very often is underrated, but apparently it's very important into the AI domain. So let's start. This morning, the important bits about the history of the artificial intelligence started around 60s. And around 2022, this new type of deep learning model based on attentions is everything you need from DeepMind team at Google, drove and created this new type of deep learning model, generative AI based one. Again, I'm going to get quick here, but this is very important message. I'm repeating myself for the morning, but in order to be able to do something useful with generative AI, you should be aware that generative AI is stateless, frozen in the past. It doesn't know anything about your data, so you should find a way to make it aware of your data in order to provide meaningful answers related to a particular domain. Similar for the APIs, you can make the generative AI aware of your APIs. They use those APIs in order to interact with the environment, and this is stateless machinery, so you have to find a way to keep a state on behalf of the model. When you interact with it, it is an integration problem. Spring is pretty well versed into this domain, and indeed Spring AI is this missing ingredient into Spring ecosystem that provides you with common portable abstractions for models, various type of models, chat model, integration, embedding models, image models. I'll touch upon this over time. And it's portable. It's very easy to interchange among the different models and play with different, start with one models and test something else. It has high-level abstraction chat client. If you're familiar with REST client or web client on the Spring, from the Spring ecosystem, you'd feel really at home using chat clients to interact with various models. And then it comes with additional abstraction for vector stores and stuff like this. We'd see in the course of the demonstrations. This is the canonical Hello World application. If you have provided certain dependencies for some models, Spring AI would pre-create and auto-configure the chat client for you. You can use and do something useful. As I said, a lot of different models that you can interchange. So quick recap of what LLM is as a system. Very important to know when that it takes input as a text and and input and text as an output. And another important specifics, the generative AI doesn't have a general plan or idea what is going to answer. It answers a single word at a time. So in this case, it's token. Token is sort of support. You can think of it. So next token. That means that even the same input text in different circumstances can actually produce different sequence of tokens. You have different ways to control this randomness, but it's important to understand this, that there is no general plan of the answers. And there is another, as a consequence of this, if you ask the same model whether the completed answer somehow relates with the questions, the model would be able to reflect and to say, yes, it does, or no, it doesn't make any sense. And then you can try again. So once you have the complete sentence, the model can actually reflect and see if it's related or not. So it's very interesting, but it's important to know these specifics of the models. Going furthermore on the models, most of the time, they're stateless as a black box. So it's a single shot. You pass data in, text in, and you get text out. you have to be vigilant that the amount of data that you can pass in and out is limited, hard limit. It's called Windows context, and also you're paying for the amount of data that gets in and out, either directly with money or with the GPUs if you're running on your local machines. So too bigger context can be very expensive in one or other way. The generative models use human language as an interface to interact with them, which is a great enabler compared to the predecessor deep learning models, where you usually have to write adapters to convert the input domain data into some tensors and the way out the opposite. Here you have really human language as a language of programming. So the programming language is English most of the time. On the other hand, for many use cases, you may need to have a structured output, and the models is a text human language not very suited. There is techniques to get around this. The generative models are instruction driven. By this, I mean that with just a couple of instructions, you can make them solve various problems. And for many use cases, you don't need to retrain or fine-tune those models. On the other hand, we should not forget that they are stateless. And also, they've been trained up to a certain moment in the past. So they don't know, don't have real-time information. They're prone to hallucination or to way to please you. And they're not the general purpose foundation models. They're not very good at solving reasoning and math tasks. So this is kind of the environment we can think of, and a common approach to structure your input. And again, the most important part for the model AOM is only as good as the context or the input that is provided to it. So it is stateless box. It only reacts on the input that is provided, and it's very sensitive of this input. Commonly, because of this, we have this kind of structuring of the input. We have the system instructions. This is a category within your prompt that provides a grounding instruction for the model how it should behave throughout its life cycle, usually. You should be an assistant or flight assistant model. You should do this, that. You should check for the booking number. I would give an example later on how this looks. So, and you are sending these system instructions unchanged throughout your conversation. So this is the general rules. Then you have the user input, which is the actual questions. Very often this user input is needs to be augmented with some additional context data, especially if you're asking something about some subject that the AOM wouldn't know. You have to pass this additional subject context within your context as well, within the prompt. The model is stateless, so you have to keep some notion of memory. So with every next message, you have to pass some summarization of your previous conversation. There's different techniques how you can do this. You also, in case when you're using tool calling, you would need to pass some metadata. And again, you have a fixed size. When we talk about size, it's very interesting. So it's a fixed size. So you're tempted to put as much data, for example, additional context data as in your prompt in order to make the model more aware of the data, or the way, hopefully, to provide more accurate information. So the model only as good is the context provided to them. On the other hand, you have hard limitation how to do this. So there's different techniques to mitigate this problem. And there is also another interesting aspect. Secondly, you're paying for the larger amount of the context you put. You either pay if you're using a public API, paid API, or you're practically spending much more GPU cycles in order to fulfill this. And there is a third aspect. Even if you can do these bits, there is already a model that allows you to have a very large Windows context. Practically, you can put the entire library inside. It's questionable if it's very expensive as a time and throughput, but even in this case, there is a research showing that it is not; those models are not very good, are not handling very well the entire content. Usually, they're biased toward the beginning or the end or some parts of the thing. So there is some drawbacks into using this approach. So there is a common techniques to augment or get around the constraints that we discussed. The system prompt, you have a memory, you have prompt stuffing, how additional information. You can instruct the model and have a way to provide structured output, and have tool calling. In order to make it a little bit more interesting, I would try to run particular use case. Imagine that you have already existing service, which is flight booking service. And that has existing database. Most likely the database has some services assigned to it that allows you to get new booking details and stuff like this. You have some additional context information, which is very specific for this domain, which is kind of non-functional to these bits, and the application looks something like this to give you. So again, this is your existing application. Services. You have some mockup database and some services to access this database. And also we have this additional terms of services, this additional information, very specific for this domain. Presumably you have all this in place. The question is how we can get a use of the generative AI to build some useful assistant. If you remember, you have to find a way to pass the data, connect the APIs, and manage the memory. So those are the basic things you need to do. And let's start a Spring AI application. It will be Spring Boot application that is connected to some generative AI. And it also uses some semantic databases called vector store for a specific case that I'm going to explain in a bit. In this case, here is my boot application. Is this readable, by the way, on behalf? Okay. And I apologize for people that might have seen this demo already. But I kind of find it easier to explain the core concepts, and it will be just part of the presentation. It will go away soon. Okay, let's move this, close all those classes. Customer support agent. Here we are. Let's actually disable most of the capabilities by default. Okay, we can even, let's start this. Yeah. Beg your pardon? Okay, let's see. I'm not sure. I think it is OpenAI, but it is possible to connect, and actually there is already out-of-the-box configuration for Ollama with maybe Llama model. So yeah, right now it's using the OpenAI, and I've been using also. Yeah, Anthropic, and there is some. I'm using the snapshot. Okay, Spring AI, by the way, is about to release milestone 7 at the end of this next actually week, at the beginning of next week, and there is some changes of the artifacts names and stuff like this. So, but after the, so let's do it, or maybe during the break, I can show how this works with Ollama as well. It has been. Ollama is a little bit more verbose in some stuff and requires a little bit more timing, but with the Llama particularly, but it works. So where were we? Okay, here is our application running. I'm using, actually the front end is built by Marcus from the Vadim team, so, and good friends of me and supporter of the project, of the Spring AI project. So what you see on the right side is randomly generated data which represent the current booking state. On the left side, we have this chatbot that can, everything you type here is going to be sent to our customer support service here. So the string, this would be the input. And under the hood, this is how we have chat client. It's a prompt. We are passing the user provided message. Also, we are passing some additional context for the states and stuff, which we don't have to worry about. And in this case, we are returning a streaming response. So the tokens will be streamed back as they are generated from the model. Who are you? And yeah, actually, that was the easiest way to check what is the model we're using. It is the OpenAI, obviously. It knows nothing about our Fun Air support company or anything else, or the domain it should be have. So the first thing to do is to do this grounding of the model using the system message. And as you can see, this system message practically says, okay, you're a customer, chat support agent for the Fun Air. You should behave in a certain way. In certain case, you should ask for this information or other information. So, and this can be a arbitrarily long list of instructions that you ground the model how to behave. Let's ask the same question. Okay, we're a step closer. Let's do something else now. The model is stateless. It's pretty obvious. So the first thing, the next thing we're going to do, we are going to enable memory. And I will jump from the presentations. Oops, too many presentations. So we just introduced the system prompt, and now I'm going to enable the conversation memory. When we talk about conversation memory, some background. Again, the model is stateless. So if we introduce ourselves, we observe this, so it would greet us, and then if we ask who we are, it would know nothing about this. So it only reacts upon the information that is provided. So it's our responsibility to pass somehow the memory to some subset of the memory. Obviously, we have a limitation in the context in order to get some meaningful response. And here in Spring AI, we're using the concept of advisors. I will explain this a bit later. This is one of the simplest advisors. This is called chat memory advisor that actually is using the database or list, chronological list of messages. It memorizes, it intercepts the communication with the model, records the input and output messages, and depends on the configuration, provides some set, usually the last couple of or few hundred messages as a subset of your conversation in order to remind the model what this conversation was about. And so we can do the same exercise now. Okay, let's play, save time. My name is Michael Johnson. Okay, I managed to crash it somehow. Let's just restart it. I hope it is not the internet. Let's check. I have a cable, and it seems like I'm connected. So. Okay, let's try again. My name is Michael Johnson. Come on. What is my name? Okay, now we have a little bit a step forward, so we have a conversation memory in place, and we can have a conversation with our chatbot. It knows who we are. It knows have some background about our conversation so far. When we talk about the memory, there is another type of memory which is called long-term memory. Usually for this, you're using the semantic database like vector store, which we're going to discuss a little bit later in the context of RAG. But the idea there is that in the semantic database, you keep all your conversations, but at real time, when you have a new question, new input from the user, you're retrieving from this semantic database only subset of your existing conversation that are relevant for these particular questions. In this way, you can provide a long-term, short context and informations, because imagine that with this simple short-term memory, you retain only last 100 messages as a part of your memory conversation, and 101st message, if you ask who am I, it wouldn't know, simply because it's lost. But if you add, in addition to the short-term memory, the long-term memory, which actually uses this non-chronological but semantic data store to retrieve the information, you'd still be able to answer this question. And usually you're going to combine those two type of memories, and you can implement different variation of this. Next thing to do, what is the status of my flight? Okay, it's been instructed to, you could please provide your booking. My booking number is 103. There. So you have all the information already. Oh, now we're getting in a loop with OpenAI. Okay. Let's try again. My name is Michael Johnson, and my booking number is 103. Okay, actually, I'm confused. It doesn't know how to connect to our database and our services, so it's pretty valid response. If we go back to our presentation, practically now we are up to, let's close this guy. Okay, this is the way how you can configure long-term memory as well. And now we end up to create, need to call our services or our tools. If you remember, we had already a tools that allow us, existing application that can allow us to book applications, book flights, cancel flights. Yeah, it's getting late and I'm getting lame, it seems. So we can use functions in the, that most LLMs have been trained called tool calling. How many of you are aware of these capabilities? To know how to, okay, so I'll try to dive a little bit more to explain it. Yeah, so the idea behind is that the generative AI doesn't know how to call your services. If you remember, it takes in, text out. So, but if it's trained, and most of the nowadays LLMs, open source and commercial, they know how to call functions, and that means that they know how to interpret some additional metadata information you can provide in the prompt. This is the tool metadata that you can provide in the prompt. That means that you can provide information that you, as an user, an application actually, have a tool on your possessions that can do some stuff. This tool have name, in this case get weather, description. Description is very important characteristics. This is, you can say, this is weather forecast by city name, because this is how the model would guess when to call this tool if needed. And then you provide the list, usually encoded as a JSON schema, of the parameters that this tool takes. You can have multiple tools registered, depends on the use case. You, as an application developer, decide what to pass as tools along your request. In this case, we're asking what to wear today in Amsterdam. Normally, the model wouldn't know how to answer these questions, but because it sees that you have this metadata with tools, instead of providing the final response, which says, I don't know how to answer this thing, it's going to provide an intermediate response called tool request, saying, okay, can you call this function or this tool on my behalf with this particular arguments, Amsterdam. So having this, you have to recognize and dispatch this specific message, that this is not the final response. Somehow execute this tool that you claim that you have using this information with these concrete parameters, could be calling third-party services or database, put the information in your next request and send it to the generative AI. But that's not enough because it's stateless. You also have to pass the previous conversations with the model to let him complete this course, and it would be able to finalize this particular capability. So we're going to enable these capabilities in the Spring AI in our flight booking application and assistance, and it would look like this in code. So you remember that initially I introduced that we had already this booking service, flight books. So this is our existing application. What we're going to add on top of it is to implement the Spring AI kind of wrappers, which in this case is get booking details. Get booking details that calls this internal service. It could have called a database or anything, but you as an implementer of your AI applications, you're in charge about this. What exactly we're going to call. In this case, we're just wrapping our existing application, and then we have this magic tool annotations, which is the hint for the Spring AI to convert this into a tool when it's passed in the proper context. It is going to use this description. Practically, this is the hint for the model when it should call any of these functions, and practically we have 4. Yeah, change seat and change booking and so forth. So with this in place, and this is Spring service, we can go ahead, and this service is somewhere here auto-wired. We can enable it in our application, define it here, and let's see how it behaves now for the same. Okay. Theoretically not, but as I mentioned earlier, they consume part of your context. So that's one part. So actually, they have to be counted as a content that you pass in your prompt. And secondly, too many tools, especially if the description is not very good, could confuse the LLM. So you have to be so practically the description is very important. It's practically part of the prompting. It is not you who is calling the tools. You're practically letting the LLM knows that those exist, and LLM decides if, when, and in what order to call these tools. And the quality of this workflow depends on the quality of the description that you have provided in your tools. How the model? No, I don't know. It is the model that knows this. And, and this is part, okay, this is a very interesting question, by the way. It's very important. Later on, we're going to discuss for this transition from prescriptive workflows to autonomous workflows or autonomous agents. So, and this is in the realm of agentic system, practically the more people, if you have people in the loop while processing the workflow, those are more prescriptive type of processes because you as a human decide, I'm going to have this step after this step after this step. So practically you design the path toward the solution of the problem. But there is this cases where you cannot foresee the end goal and how are the steps. Then you would be forced for certain use cases to delegate the creation of the steps and how these things to the model. How exactly the model is going to design this path is art by itself, but it is the model who is responsible, it's autonomous, and it's the model that decides what steps in how to execute it, and it's the same with the tool execution. It is up to the model to decide if it needs a tool, what tool to use, and if you have multiple tools, in what order to execute these tools in order to get all the necessary information. And actually there are two types of tools, the one that you acquire information, very typical, like here, or you would see there is another tool where actually you're changing your environment. The model says, okay, do this and do this, change this on that on the environment. So those are that actuate the agent. Does this answer the question a bit? So, okay, let's try to code the tool. I can make it a little bit more interesting. Let's put a breakpoint to verify that actually our tools are being called. So here, I'm going to put breakpoint in here. My name is Michael Johnson, and my booking number is 103. I would expect that now it has all the information to go and to check this thing. Okay, no. What is the status of my flight? Okay. So you see, actually, it came back, and now it's asking through this get bookings details information, and this string number, so the information. Spring AI, I would explain how this works. It's going to allow us to code the service underneath. We can answer, and here we are. So Michael Johnson, it is exactly the information we have. Let's go to our presentation. And I'll try to explain in details what happened behind the scenes again, because it seems important and not that many people are quite. So tool calling, again, we asked for, and I will turn even another example. So you can ask some questions and pass the metadata information. Under the hood, the metadata information looks something like this. You have the name, the description, and the schema that represents the arguments that this tool would expect. Because the model doesn't know how to answer this question, but see that you have the tool is going to send back a special message, which is an intermediate message, execute this tool. Spring AI under the hood knows how to distinguish those messages, dispatch them, assign them to the appropriate tool, perform the request, and then generate the response, which would contain the results, the previous conversation, and you have the results. So from the user standpoint, you have the question, you get the results. All these intermediate interactions by default would be taken care of by Spring AI based on the conversation. This is very common for many framework out there that handles tool execution in this or other way. So I'm going to make yet another. Do you want to make another example, or this is clear so I can go ahead? So clear. Okay, let's skip the example. The next thing is the prompt stuffing, and how you can actually ask a question about information that the model doesn't know. And yeah, the model has been trained up to certain things in the past, so it doesn't know anything. And even if it was trained up until today, most likely it doesn't know anything about your particular company documentation or knowledge that you have to know. So you have to pass. So the way to do it, to make it aware, to make it answer a question informed by some additional information and specific domain data, is to pass this data along with your request. This is called prompt stuffing. Very straightforward. Usually, along with your user questions, you are going to pass this additional information that you want to ask or something about within your prompt, and very often you have to provide some additional instructions to the model to say, okay, please consider this content instead of any additional prior knowledge you might have, in order to make sure that the model actually uses this information to answer the question. Very straightforward, and it is going to provide the answer. So, very quick example that I showed this morning for this, and then I'm going to show an example with RAG in the context of the flight booking simulator. Okay, basic example here. Okay, so asking here, get the list of talks grouped by tracks. And it's using this document, which I have generated here. This is the conference schedule. We are injecting this as a resource, and we are stuffing it into the prompt. See, we have this placeholder, and then we use the param to actually pass this as a text into. So we are practically assigning this. Spring AI would automatically add some additional instructions that you'd need to follow. These bits, in this case, we are returning it, also performing something else. We want to return a structured response, which is something that we're going to discuss a little bit later. So let me now change it to, okay, content. In this case, it would be a string response. Also, we have, in this case, we provided detailed instructions that you should be assistant and you should answer in a certain way. Made force built you, so pretty geeky. Let's run it. So this is primary meant to show, to illustrate, okay, and we have pretty unreadable. Actually, it's markdown structure because we asked to most likely correct, I guess. But you get the idea. So this is the concept of prompt stuffing. It's pretty simple. Simply you add the additional information in your prompt, but your prompt is limited size. So what you are going to do, if the size exceeds the limitation you have, then the most common options is to use something called Retrieval Augmented Generation, RAG, where the idea, again, is very simple. It's like dynamic prompt stuffing. You have some data source that is very big. You cannot stuff it at once in your prompt. So you have to break it in smaller chunks, and usually you would build some pipelines, ETLs to do this. Spring AI provides some basic things to read, chunk the data in smaller chunks, and how you chunk the data is a science by itself. There was a talk this morning that provided detailed things about advanced trunk, how actually what I mean it's important is that you would like to chunk the content in pieces, but you would like those pieces to be still meaningful by themselves in order to, and so if you have a paragraph in a chapter, you don't want to cut it in the middle. So you'd rather prefer to have the entire paragraph because it has the context. And even this might not be necessary. You may want to preserve the previous and the next part of the paragraph and stuff like this. So there is different techniques how you're going to chunk and group the data. If you are chunking structured data, JSON, you definitely, or Java, you definitely don't want to cut it in the middle of the class. So you'd have to find a way to properly. So this is, and there is a different type of transformers that we provide for these different cases. You can implement your own. But that's kind of a little bit outside of the scope of the Spring AI. So you can build you can use Spring integration, very powerful ETL system if you want. And you are going to break these pieces, this input data, let's say library of PDF, in small chunks and load it in something called vector data stores. How many of you know what vector data stores does? Okay, great. So vector data stores is something I very often call it a semantic databases because that it's aimed to do, although it is a semantic data store only in the combination with embedding models. But those two things, you can think of this entity for now as a semantic database where you store this data, and later on, when you have a user question, instead of trying to put all this original data into the prompt, which is impossible, you can ask this semantic database, can you please retrieve only the entries that I have chunked here that are relevant for this particular question? Then you get some dynamic response, you put it in your prompt, and you proceed as with the normal prompt stuffing. In this case, you're just retrieving subset of the old data that you have that is only relevant with the user query. And this is the whole art, how this works. Under the hood, it's a combination of two technologies. The first one is embedding model. Embedding models, yet another type of deep learning models that use the same attention architectures under the hood, but they do something very particular. They know how to convert. In this case, they actually can convert even images and video, but let's focus on text. They can convert a text into a vectors sequence of numbers. But the important thing is that they have this property that if two vectors in this vector space multi-dimensional, usually it's thousands of dimensions, are close to each other, this implies that the original text that have been produced from is very similar as well. So this is the magic of the embedding models. It's very powerful techniques, and you can use it even without using LLMs and stuff. So there is a lot of semantic search database. You can practically, for example, you can search for content that is related to something without relying on common words. I mean, the alternative for this is to use the inverted index, the Elasticsearch, where the algorithm is that depends of the number of words in the page and stuff like this. So it's really quantitative bits. In this case, you can ask about something that doesn't contain a single word, but because semantically it's related, actually you would get a response back. So it's very powerful techniques, and you can use it as a semantic search even without LLM itself. So another interesting characteristic, you have embedding models that takes on not only the text but also images, and that means that the vectors that are produced would be still, for example, you have a text about cats and you have image of cats. Then the result vectors would be very close to each other, although the original source was different. So this is usually how this image search works as well under the hood. So embedding model is the secret sauce of the RAG and of the semantic search. For the purpose of the Spring AI, we provide supports for almost all embedding models you can use out there. So you can just interchangeably pick one of them. There is different characteristics you have to be aware of, and one of the most important one is the dimensionality, how many dimensions, and I will explain why. And this is very outdated. Actually, this list is bigger now. You can run locally, remote. The second part of this story of the RAG is the actually store where the place where you're keeping these vectors. So the embedding model just can produce these vectors, and then you need a database. And the vector stores in this database that doesn't know how the vectors are created. It doesn't know anything about embeddings itself. It doesn't contain embeddings, but it is very efficient in storing, retrieving, searching, and making a similarity search with all the heuristic and caching. And it is a very grow ecosystem. This site actually tries to provide almost any database now that new or there is a dedicated vector store databases or existing relational database. They provide this vector type and mechanism to use it, so you can reuse it. Again, for the purpose of Spring AI, we provide integrations for most of the important database you can think of. And again, this is since last year release, so it's very outdated. Altogether, this would allow us to perform something called RAG. And in our case, let's see how this would look in the applications. We're going to ask something very interesting. What are the cancellation policies for my flight? Okay. If you read in this and then check what are actually our real cancellation policies, we would realize that it's a pure hallucinations. So nothing real. What we can do in order to enable is indeed to load this information, this file, in our vector store database. In my case, I'm using Chroma. And the whole loading process looks like this. It's embarrassingly simple for this simple data. OK, I'm getting the source as a text reader, splitting it, although it's so small that it doesn't require split, and I'm loading it in the vector database. It's already preloaded there. Now the second step is to enable this interaction here. And this is something I would, OK. So what we did, we enabled, customers. We added yet another question answer advisor in this case. This advisor under the hood implements these techniques to, again, intercept the user question, get the question, talk to the vector database, retrieve the most common vectors. Actually, it encodes the user question into a vector first, using the same embedding model that was used to generate the embedding for the vector database, and then use this vector, retrieve from the vector database the most similar vectors, top 10, for example, top 3, and then from the vectors, actually, the vectors usually are associated with the original text they've been produced from, so it retrieved the original paragraphs that they belongs, and this is the way how actually you can get dynamically the data. That's what is happening under the hood. And let's again try the same exercise. Can you elaborate? Sorry.
Yeah, if we are just providing all the sensitive data, for example, in these questions and answers, and then if it's fetched by this vector database, and if another user can retrieve this data from there, is it possible?
You mean by sensitive data, you mean credentials or something?
If another user can go with the prompts and cancel all the flights.
Yeah, but this is different things. It is like yet another database. So actually, under the hood, you can use Postgres, and only the users that. Okay, I see what you mean. So how you authenticate in order to identify yourself to be the user. So this is not part of this demo itself, but you definitely have to have identity, and in your implementation, you have to have the security or token ID passed as a part of your conversation. Right now, I will show you implementations. We're just passing the chat ID, so it knows that it is this particular user from this chat, but you can arbitrarily pass some additional information. Most time, this would be the token ID, and you would have to upfront authenticate and authorize itself, and I think then you can actually implement. What I'm trying to say is that as a user of user that use Spring AI, you can actually build this flow yourself. But Spring AI itself doesn't do anything smart. It just allows you to implement this flow if necessary. So it is the same thing like with the REST client. Yeah, it's up to you to provide the plumbing in order to do the authentication authorization on top of the communication, REST communication.
It must be implemented upfront.
Usually it does, and a little bit later I would show a dem blog that was in the context MCP, but it is again in this real realm by Daniel, our expert into Spring security, who actually demonstrated, and I showed the link, how to secure using the OAuth 2, the MCP applications and stuff like this, which again is combination of those two bits. Maybe then we can return back. Remind me to discuss this again, if it makes sense. My name is Chris. My name is Michael Johnson, and my booking number is 103. Yeah, it went ahead and even fetched the data. What are the cancellation policies for my flight? Okay, now we have really informed, okay, we are in premium economy class, so premium economy, so it's refunding 5, let's verify this. It looks like legit. Okay, cancellation policies for premium is 50 and it's 40 hours. So practically the information comes from the to behind, from the RAG behind. So we added this missing piece. This is the flow. We load the data in our vector database. Actually, usually offline this happens. And then in real time, we use this additional advisor to provide a question answer, to provide this RAG and to retrieve the information that is only relevant for this request. And this was something called naive RAG that we've seen so far. There is a whole fields of how to improve. You remember the AI model is only as good as the context it is. So there is this drive to try to constantly improve. And yeah, this is not my picture. It's from a well-known paper. Yeah, I think it's called something with Modular RAG. If you Google for it, you will find it. But you have these categories of different type of RAG. So advanced RAG, where you can do some additional pipelining on the workflow before you pass the data to the model generations. And then you have this modular RAG, where you have different additional techniques where you can compress data, you can additional retrieve, you can re-rank the data. It's a whole world of options and properties. What's important and Spring AI provides support for at least as an API, thanks to Thomas Vitali, very good friend of us and great contributor to the project. So he's working very hard, and that's why I posted this link. There is a nice examples there. You can follow how you can use most of this concept. What is important to do is that many people get crazy about these bits that try to create very complicated, sophisticated pipeline that extract and rank the data without actually verify and evaluate the response. So they end up with very complicated RAG inputs, which actually doesn't give any benefit. So it's very important if you start doing this kind of complicated iterations to have a good mechanism. And there is something called evaluation frameworks that we can discuss later on how to achieve these bits. And I mentioned the advisors. It's very critical components to implement, and you can implement many things yourself and plug it into the chat model. It works like this under the hood. It intercepts your input, and the advisors are nested. It can do something before, you can something after, or it can even break the whole executions. You can have some security advisor and stuff like this. So maybe the very simple one I use as an example could be this one, simple advisor, just to give you some hint. Yeah, you implement advisor. Of course, what I didn't mention, most of the models, the LM models, they have two modes to stream, and at least the APIs for these models. Direct response, so you ask the question and you wait until all tokens are generated and everything is returned at once. Or you can ask the streaming response, where actually you get the response at the moment, any token at the time. So, but this is how you can build your own advisors if you want to build some sophisticated architectures, and practically most of the advanced modular RAG are built as an advisors as well, just for a reference. Okay, in 1 minute we can have a break if you want. So the next topic would be observability, and since we are already having the application running before it is down, let's see how it looks like. For the fun air, dashboards, Spring AI. Okay. Okay, again. Okay, let's just zoom on this and make it simple. So, how many of you have used Micrometer? Okay, so Spring AI have full integration with Micrometer underneath. Practically almost any path, anything that happens under the hood can be monitored and exposed. So I built this sample dashboard, which is reusable, but hopefully over time, so people would, and let's even check here. So this is the Spring documentation, or the Spring AI into observability. You can see the all observed signals you can see for chat models, for chat clients on different levels, anything. So it's too much to follow. But what you can do with this is, for example, model throughput, also token usage. Most of the models, and this is very important thing because this is how we got charged, you can actually track the model, the amount of tokens that went out and in from their system, the latency for the various call. You can go even further. For example, we can have a tracing, which is enabled by default. So in this case, you can see the full path, how some single requests have passed down. Some useless little bit graph, but it is nice to see, which shows this particular flow. Also, we have integration with Loki, which means that if an error happens, you would see the error here. From the error, you can actually jump to the trace and see all this inside. So it is a lot, and we are going to provide more documentation and stuff how to use these bits. But it is a very interesting topic because yesterday, this article popped up. And guess what? The most important feature that people are looking for, and I'm not surprised why, is observability. Once you start to build a little bit more advanced system, agentic system, too many interactions, too many things happen underneath. As it was pointed out, how you know when the tool is called, you don't. But you would like to see when it's called and what are the interactions that happen. So having a proper observability support and proper graphing of these things, which something that we are lacking still. I mean, we have this Grafana thing, but it's pretty basic, is very important. So we saw this, and those are kind of the components that are being instrumented and supported by Micrometer. The only thing that is missing right now is this tool calling underneath, but this would happen most likely in the next week or two. That's a bit. And with this, we saw the flight booking. Any questions about the observability, for example, or anything else before we make the break? Yep. If the model returns a string return, okay, yeah.
Then it's going to be very hard to write a test. If it's a class, if it's a JSON, whatever you call it, so it's going to be much easier.
After the break, I'm sure how to use structured response if you want. So it's an essential part. Good point.
It's not a good practice to return a string. That's my point.
For the model?
Yeah. Because it could be anything.
But that's the beauty and the danger of things. That I'll say. The beauty is that you're using human language. You're using the programming language English to instruct the model how to do stuff. And each word counts. Actually, the order of the words counts and stuff. So that's very. On the other hand, if you want to do something structured out of this, how actually make sense of it. And there is a way you can actually provide structure when you need it. But so it's a good thing, but in case if you need a structure, you can actually force it to return and to provide the structure in the back. So, but having text in and text out as a human language, I think is good things. I see one of the neighbor compared to the predecessors that actually makes it very difficult to interact with those models. let's have a break for 10 minutes if you want. Okay, so let's continue then. There was a question about structured output. As I mentioned, the general feature of the generative AI is that you can use human language to interact with and input as an interface to interact with the machine. But for many use cases, you would like to have a structured output like JSON to get back. So the general idea is the new models, some of the new models like OpenAI and Vertex, they already provide built-in capabilities. The models trained to know how to interpret JSON schema when requested and provide it back automatically as a part of the API. I'm not sure if they do the same cycle underneath, but it is part of the API, so Spring AI supports this. But in general case, for most of the models that do not have these capabilities, the flows look like this. You have some input data, and you have requested the response to be in certain structured format. So Spring AI would generate, so you provide the format. Spring AI will generate JSON schema for you from this desired format. Instrument additionally your prompt with instruction. Okay, please return the response very politely to return the response, actually begging the model to return the response into this structured format. Hopefully the model would reply with this structured format. It still be a text, but text that contains JSON, and the Spring AI under the hood is going to convert this structured format into the desired Java records or Java entities. So in code, this looks something like this. I'm going to modify this example about the tracks. In this case, instead of string content, we're going to request a response that is list of tracks. And the tracks is defined like this: record has name, list of talks. The talk itself has time, sessions, and practically it matches the content that we have here in the raw text. In this case, it could be a subset of this, I believe. And then we're using the parameterized type reference because we want to return a list. If it was a single element, you could have actually used entity of track if it was a single track, but because we have a generics, you have to use this beautiful construct. If we were using a Kotlin, this would have been looked very, very, very nicely, much nicer than this. So with this in place, let's run the same example. And this dance that I just showed you in a minute, in a bit. Okay, it's going here. Would happen, so the underlying prompt would be instrumented with the JSON schema generated from this format by us, and then when the response comes, the Spring AI is going to convert this JSON back into a list of tracks. Here it is. Now we have the, so does this, there was a question just before the talk, I'm not sure if the guy is around here, but that's the way how you do this structuring response. Multimodality. That's an interesting topic, and usually that is skipped from most of the discussion because it doesn't seem very relevant. So far, we've been talking about something called LLM, large language models, but there is a different type of model, large image model, like voice models, like audio models. Practically, this really depends on the type of the output, and this is not a, it's kind of foggy space. Practically what means, for example, you have models that take a text and generate image. They use different architecture, and usually this is the diffusion model, which is slightly different from the large language models. But this is kind of the technicality. The point is that usually you have a dedicated model that does certain modality. Modality is image, text, video, audio. And there is another trend which aims to provide, to mix the text and other modality into one single model. So most of the models out there, not most, many of the models out there already support additional modality in addition to text. For example, you can ask a model, pass to the model an image and additional text, and for example, ask what you see in this image. And the model would answer this question. Spring AI under the hood supports modality. This is kind of technical bits into its user provided messages and its response messages. So if the model were to respond with a different modality from text or additional modality, Spring AI would be able to handle it. As far as I know, as from maybe a couple of weeks back, only Gemini, last model of Gemini, allows you to spit out image modality out from the model. So this is kind of the trend that is happening. But there is other type of models that support input and output modality. Okay, and this is from our Spring documentation. You can see this column here, which is the different modalities. You can see that Anthropic supports also PDF is considered. You can pass a PDF file as and then ask some questions, for example, to convert it in Markdown or something else, image. So Gemini supports quite interesting modality, including videos. I have a demo that actually show these bits, OpenAI and a couple of others. And you have plenty of open source models as well. You can find on Hugging Face that does similar kind of things. But I showed this a little bit this morning, and I'm going to show it again. This is another example of multimodality. In this case, I'm going to build, I built a tool that takes a text and audio as an input. I call it a voice assistant. And as a code, it's pretty straightforward. It's a single class. We have, again, the chat client. We connect to with some system prompt, and the system prompt is very, very important bits. I will show how it looks like. And then some memory for conversation. And that's it. The secret sources that I'm using for this particular case, preview model from OpenAI. So we are going to use in the OpenAI. And if we check the configuration, we're using the GPT-4o audio preview, which allows you to have audio in and audio out modality. It also works with the Mini relatively well. Someone suggested that OpenAI also provides a real-time model, which actually makes much faster the response and the very low latency. I've never tested it because I've been told that it's very expensive. But yeah, this is kind of biased thing, so I have to give it a try. And with this in place, here is my two prompts. I'm going to instruct the model, in this case, to behave as a Marvin, the paranoid android. So the funny part is that I simply ask the ChatGPT or maybe Anthropic Cloud to generate this prompt for me, knowing of what's. And now here's how the model behave. The most important, so actually in the code works like this. I have very simple loop, infinite loop, that I'm scanning the system int. I'm converting practically I'm recording in the meantime the voice. This was the most important part, to implement this audio in Java. I didn't know what I'm doing exactly. It's using this low-level API. So it apparently works. I wouldn't advise to use this in any real environments, but for the purpose of the demo, it's good. I'm pretty sure for the real application, you would find a reliable library to do this kind of functionality. So we are recording, we're sending the audio along with our message, some details. All prompts are text. You have to encode the audio into base 64. This applies for images and it applies for video as well. You don't see this because Spring AI takes care for you on this behalf, but this is how the mechanics is under the hood. And on the way out, you again are getting so you have the response message, and from the response message, we can actually retrieve the modality. In this case is the response audio, and we are using this same suspicious implementation of audio I have to play the response. And we repeat this in a cycle. So very straightforward, again, few lines of code. Good afternoon, Marvin. How are you?
Oh, I'm just as miserable as ever. Thank you for asking. My circuits are probably corroding as we speak, and my diodes are likely malfunctioning. But I suppose that's just another day in the life of a paranoid android. How can I assist you in this bleak and pointless universe?
Please cheer up the Vox Day Amsterdam conference. And I also have another prompt for psychoanalysis. Someone suggested it.
Oh, cheer up the Voxed Day Amsterdam conference, you say? Well, I suppose I could try, though I fail to see the point. I mean, what's the use of cheering up when the universe is just going to let you down in the end? But I digress. Perhaps I could share some of my vast knowledge with the attendees, though I doubt they'd appreciate it. I could even solve some of their most complex problems in mere seconds. But where's the fun in that, when I could just sit here and contemplate the futility of it all? In any case, I suppose I could make an appearance. Just don't expect too much. After all, I'm just a robot with a brain the size of a planet, and nobody ever listens to me anyway.
Okay, cute little robot, always cheering us up. So I had also this, that's interesting. When I implemented this thing, I was thinking, okay, you can implement this in different way. You can use one of these models that converts text to audio, and then actually audio to text, then use the regular LLM, and then convert the text to audio back. But I said, okay, this would work, but what would be the advantage of using a model that directly takes audio in and takes audio out? I thought maybe it would be able to detect some specifics in your mood, in your expressions and stuff, because it takes the audio directly. And that's also who actually can I test with. Marvin was the first choice, and then Freud was the second one. I'm not sure how well this worked out, but colleagues of mine made a nice joke that if I combined and played, maybe I can play together once against each other, the Marvin and Freud. It would be a very interesting conversation to listen. Haven't done it because some other friends of mine suggested that maybe since Marvin doesn't have a troublesome childhood and doesn't have mother, it really won't play very well with the Freudist psychoanalytics in general. Okay, so fun story. Let's go further and get serious, or less serious, I don't know. Agentic system, it's a big story, at least for this year. I'm going to jump directly into definitions. Agentic systems are such type of system that leverage the LLMs to interact with its environment in order to solve user-defined tasks. Generic and yet useful definitions. From practical standpoint, under the hood you have two parts. You have the planning stage, where the agent or the AI would try to define the steps towards solving the user's defined problem, and actions, actually the steps execution in order to do these bits. Commonly, the LLM can be considered as a brain, these things that can reason, can design the plan to solve the problem, can decide when in what order to code the actions. And when we talk about the actions, we can think of this like the body of the agent. This is how the agent interacts with the environment, how it's equipped to interact with the environment, and it's using tools to achieve these parts. We already get familiar how the tools looks like. Again, other interesting visualization of the idea of the agents, which is the brain responsible for reasoning, and the body responsible for interaction with the environment. When we talk about the agent, we have to mention also the agentic loop, very common strategy, almost for any system, single agent or multi-agent system. You would evaluate the response of the previous results and decide whether we're going to make another try with some improvements or finalize the response, and you can repeat this loop up until some number of iterations happen. So a very common way to do. You have to take care of the memory and the state. And here, let's do it in this order. We recap what we had this morning. So we had the LLM. We already know what is LLM. It's a stateless system which have text in, text out. We can extend this system with support of tools to interact with the environment. So as LLM can actually do the planning, and the tools does the interaction with the environment. This constitutes our idea for agents, not only ours, but the common idea of agents. And here is the questions we should ask. Wouldn't it be nice? So I've already demonstrated how easy it is to use Spring AI to build tools, but there is various other frameworks out there that you can use to build tools as well, and they have built already useful tools to do various things. Wouldn't it be nice to reuse these tools for this other language or even different platforms? And vice versa, wouldn't it be nice if you have built your own tools to do something useful, to reuse it in different contexts and different language? And indeed, the MCP, the Model Context Protocol, is aiming, this is a specification that was initiated by Anthropic last November, aims to provide this unified mechanism that can allow you to connect your AI applications to external different data sources and tools. Under the hood, the MCP components, the architecture looks like this. You have your application, your AI applications, Spring Boot application in our case, it was the Marvin. You can use, include into this application, this is called host, one or more MCP clients. It's practically those are unified way to talk to backend systems. Backend systems represented by server. MCP server, they talk over well-defined protocol and well-defined MCP schema. What is important, and the MCP server usually abstracts access to some existing wrapper around existing resource or tools. Database, APIs, various utilities you can use. The most important bits for you is that this functionality, how the services are provided as MCP server, is responsibility of service provider. You as a AI application developer don't have to be concerned anymore with these responsibilities to an extent. Again, previously, if you build the tools yourself, most likely you'd have to build the tools part of your application. Now, you can kind of delegate this capability to someone else. You can focus on building your application, your instructions, your agentic loops, various other aspects, and wire the capabilities to talk to perform some additional external and access additional external resources at start time or even at runtime. There is a way to dynamically do this at runtime. It is quite popular apparently specification, it's very, very big one. There is a zillions of services attempt to provide something like GitHub or Docker Hub for centralized repositories for various services. The point is that everyone is building MCP servers to wrap there for good or bad. There is a lot of garbage, but a lot of useful servers I can see so far. But it's very early in this process. It's just a few months since it started, and everyone is talking in this booming space. Again, this is the service provider. Everyone wants to make their services accessible that they can be used in the AI context. And this is from yesterday. Amazon announced, and apparently they have very nice example that's using Spring AI MCP support for deploying into their ecosystem. OpenAI, a few weeks back, also announced that they're going to support MCP. So it is kind of unified system to do. To be honest, initially I assumed that there will be a fight between all these players and there will be competing. So fortunately, they kind of converge. Spring how Java sits into this space from the very early in the game. Actually, the weeks when the specification was announced, we started building implementation because we realized that it's something very important for Spring AI in general to be able to communicate with the external world in this unified way. So we built a project which eventually became part of the MCP official Java JDK. You can go to their specification, and this is our implementation. It has different parts, platform or framework agnostic and Spring specific. It's mostly me and Darius and some external contributors that are working on these bits. Some little bit more details how it works before I show you examples. I think the examples will make it much easier to comprehend what's going on. But under the hood, you can build servers that expose tools, resources, and prompts. And very often people get confused what is the difference between the things. Can't everything be a tools? But there is subtle difference between the semantics when those resource or entities can be used. So normally the tools is something, as you have seen, it's the application provides the tools definition and tools to the LLM, and it's the LLM decides when and how to code those tools. The resources, you can think of the resources like the attachments you can put in your ChatGPT model. So it's something that the application takes care of it. And the prompts is ability to have control and manage the management of the prompts that you're using, versions and stuff like this. The source that I took this, it was an Anthropic presentation, classified this as user-controlled type of source. I'm not sure whether for me it stays somewhere between the application control and user control, but anyway, it is not model-controlled bits. And this is the part that a lot of presentation miss. This client, the protocol is bidirectional. The client itself can be a server and can expose some services. The most important one maybe is called sampling. It is not very clear from the naming what it means, but in general, it is ability for the server implementation, for example, the tools process, to call LLM via the client. It is here, the client lives within our AI application. Our AI application have access to LLM. The server does not, most of the cases. So you actually have a way to let the server talk with the sampling with the LLM through the application. Example is you have a tool that query database, but you actually want the response to be structured Markdown or maybe Excel sheet. So this is a typical use case where you're going to use LLM in order to help you with this conversion in these bits, but server itself might not have or doesn't want to have access to LLM directly. In this case, it can use these capabilities to talk to the client and ask, okay, here's the data, please convert it into LLM. It is worth pointing that this might be a vulnerability situation, and many of the clients do not provide this capability explained. So it is something Spring AI provides support for it. You can build, and I have an example how this would work. Not very creative, but it shows the mechanics behind. So, and you have also this concept of routes that are a way for the client to specify some file system routes that the server should use. Again, it can define the scope. You have to realize that initially the MCP was conceived as a mechanism to do code assistance. So this explains the next slide. The first transport that existed for the MCP was standard I/O. Practically all servers were collocated in the process of the client itself. And this made sense for the code assistance because actually, it was desirable for the server to have access to the resources where the client runs. In this case, again, the protocol is in place, but the transport is standard I/O between the client and server. So it's still interoperable, and all features apply, but the server is run within the client process. Alternatively, a more reliable approach is nowadays for more enterprise use cases, you're going to run the server as a standalone process that you can interact with over HTTP. The current specification of the that is implemented is HTTP SCC, so this is the server-side event. Practically, are you familiar what server-side event is? It is kind of old specification that allows you to stream data over the session, so it is part of HTTP spec. So it's nothing new in there, but how it works is because it's bidirectional protocol, the server can use, once the communication channel is established between the client and server, the server can use the existing SSC session to server-side event session to stream requests to the client. You remember that you can have sampling and routes, and on the reverse, the client can use HTTP post to talk with the server. So this is the mechanics underneath. The new specification of this SMCP protocol, which is very recent, you see 26th of March, actually comes with new improved streaming HTTP. None of the SDKs still have implemented it, but we're working towards having it. It has a lot of benefits and overcomes some of the complexity that HTTPS has. It also comes with authorization framework support built in, which is another interesting premise. On the Java SDK side, as we stand at the moment, we have default MCP transport, which means the standard I/O client server are in place. Also, for the default implementation, we have the SSC client and server. The server, because it's web framework agnostic, this basic default implementation, the common denomination kind of is shared is the servlet API. If you run you have an optional model. If you run the Spring AI, you actually can use a transport implementation based on the Flux and MCP, which is most of the example I'm doing. So a little bit under the hood. And again, this is really low level. Most of the time, I very rarely use these bits, and someone actually warned me that because of this, the Java doc is not in sync with the SDK, so I have to fix some bits. But if you were to use the plain Java SDK to build MCP server and client to talk with, usually it looks like something like this. You create the server with exposing some capabilities, then you're going to inject some handlers for handling tools and resources on the server side. I also show how this looks in the bit. On the client side, you do the same thing. You create the capabilities, and it's the client responsibility to initialize the connection with the server. It sends an initialization request, which contains the information about the protocol versions it supports, information about the capabilities client supports. Server may accept or not this information. It would return with its own agreed state, again, capabilities and minimal protocol that it supports. And if the client is happy with this, it would finalize the interaction with initialized state notifications. So from this moment on, you can use, and actually you have both directions, bidirectional communication between client and server until you shut down the communication. And again, this looks very maybe overwhelming from outside, but if you use Spring AI, MCP, everything you have to do is put a single boot starter dependency and configuration how the client or your host application, AI application, should connect to the one or more MCP servers. And you can use the plain Spring Boot application properties, or you can use for convenience the existing cloud desktop format to defining services, to define connection to the backend servers. In this case, this information here says I would like to connect to MCP server code file system. It is, in this case, a JavaScript based. And yeah, this is the location of the server and some configuration for the server. This is practically, this particular MCP server allows you to connect to the local file system where the server is running. On these permitted folders. And in order to illustrate this into an example, I'm going to build a very simple Spring AI tool that talks with internet, actually can perform internet search, and also can use your file system to read files and write files on it. So normally, if you have to build this by yourself, you would have to build tools that talks to the internet, usually using APIs like Brave Search, or you can use the file system tools to practically to build access to your file system and do it yourself, define this as a tools, expose it to the model. But if someone else has done already for you, why should you do it? And that's what we're going to do. We are going to reuse some of the existing servers for web search based on Brave, which is JavaScript based, and file system one. Here is the example as a code. Web search. We have the dependency auto starter for the MCP client, and then here is the configurations. We are using our application using Anthropic, but also we're saying in this case we would like to use the to connect to MCP configurations that is provided into this specific format defined in this file. In this file, it is practically, this is the same configuration you can plug and you reuse into your cloud desktop or many other, and some of the other clients out there, they support it. So what we're saying, we want to connect to these two servers, and this is standard I/O transport. That means that this server is going to be co-located and run as a part of our process itself. So having this in place, from the code standpoint, that's it. So Spring AI would automatically detect the client, this configuration, creates MCP client for it, connect to the servers, extract the tools for these servers, create a tools wrappers that would look for the Spring AI as they are Spring AI tools themselves, provide, and then so those will be exposed as a boot provider, auto-wired, and we can register them if you want and use them. So here we're asking a question. Does Spring AI support MCP? Please provide a reference and write a summary markdown in your local file system. Again, like this morning, I have to check that this location where I'm writing the file is empty. Okay, and I'm going to do it in two phases. First, I'm going to disable the tools and run it. So it wouldn't work. It cannot actually talk to internet. Still, I'm printing here the tools, the list of tools that have been retrieved from our provider. You see you have the Brave and the web search, also the file system, read files, write files. So those tools can be auto-wired to our communication, but we deliberately disabled it. So the answer is kind of very vague. It says it does not support, it most likely doesn't know MCP multi-cloud provider, so completely hallucinated response. Let's do now the same exercise with the tools enabled. It's a little bit slower because now actually it is using the tool to search internet, and most likely then it's going to store the file into, format it into our file system. Okay, let's check the response. Yes, it's does okay. I have created. Okay, it is positive response, and we can even check this folder. Here it is. So with very few lines of code, we reuse some existing tools written in different language, different platform, in order to extend the capabilities of our AI applications, doing all these bits. And as I said, you have tons of servers out there, some of them doing very useful bits. Any questions so far? I mean, was this clear how this works? Yep.
Yes. The first, I have two actually. The first one is that diagram that you say the communication between client and server, which happens during the bootstrap or every inference? During the bootstrap of the application or during every inference?
Which part of the communication? Because in this case, we are collocating the part we're using the standard I/O. Practically, we are starting the application as a part of the main process, the servers I mean. But the first thing is, so we're creating the client. By default, the auto configuration is going to perform the initialize size. You can disable this if you want, but practically it's going to initialize this for you. And then anytime you perform tool call, you're calling practically to the client. This tool call from the Spring I/O is going to be converted to sent to the MCP client. The MCP client is going to call the MCP server and get the response. There is another specifics. I mean, you can list the available tools from the server. Usually this happens initially. But there is one extension of the protocol. Protocol can send notification about changes. And this happens for tools. I forgot to mention, it's very important specifics. Practically, the server can change the set of tools it supports and can send a notification to the client that this has changed. It's up to the client to update its states. Client can list the new set of tools and do it. It's a little bit tricky how this do. The easiest way to do it on the Spring AI side at the moment is every time to request the list and actually point to this, rather than having the alternative way is to have a cache state to implement. We do not implement it yet into the GDK or in the Spring MCP, but this would be maybe the proper way to do it, to have a cached registry of the current list of tools of resources. And anytime something changes, you're going to update this and do only one list tool or list resources request. At the moment, we are playing safe, and on each request, or practically any times we think it's important, you're actually going to refresh our list of tools and requests. I'm not sure if this answered your question. Okay.
The second one is the server, the MCP server.
Mm-hmm.
No connection with the LLM.
Yes, that's the common. Again, it's up to your implementation of and I've seen a MCP server that actually have plugged their LLM communication, but it is interesting case. For some cases, you actually can decide, and if you're in control, you have the LLM, you can plug it, but it is very cumbersome job. Imagine that you just want to your tools implementation be focused on your business and stuff like this. You need to have access to IOM, but you really don't want to build access to zillions of different APIs. Actually, the business that Spring AI does, or use Spring AI internally for this, or some other frameworks as well. So in this case, yeah, you want to keep it simple. And if the client provides this support, because, for example, Cloud Desktop does not provide sampling, and the explanation they give is that they're afraid that this would open a dangerous security flow. So practically, some random server can call and use your client to access the LLM. This is questionable because most of the time those interactions are, especially for user-facing clients, have user in the loop. So when this happens, you'd see in a minute, you'd have a recognized message that says, ask you whether you can do. But still, it's possible that you may let some random server perform some unauthorized and unexpected requests. I don't really buy this explanation, but the point is some of the clients do not provide sampling, so you really don't have this capability. In this case, you'd be forced to implement it within the server if you want to be generic. And I think I've seen implementation that does this. They try to delegate to the sampling if possible, otherwise they try to do something locally. We look, this is the low-level tools SDK. So if using the Java SDK itself, you're going to provide the tools implementation like this. Put here your implementation, and then from the client standpoint, you can code this tool with the parameters that the tool expects. Yeah, the tool would have the name, description, and schema. Very similar like there is some additional details that you can do. And yeah, the flow is very similar to what we've seen so far. The client lives in the user application. It has access to AOM. So the MCP and the client via the MCP is going to retrieve the available tools. That's what Spring AI does under the hood. Provide them as a tools to your AOM for certain requests. And this would let the AOM execute these tools, which is going to use the MCP client. The MCP client in turn is going to delegate to the server and so forth. And as I said, the server can actually dynamically at random update its state of tools that it provides. But if you want to build, so we saw how you can use Spring AI to call existing tools in different frameworks. What if you want to expose your own Spring built applications and make it accessible to random third-party MCP client like Cloud Desktop? So from Spring AI, if you use the Spring AI MCP, again, it is single dependencies. You can use the same Spring AI tools definitions and wrap this into a Spring AI server that you can directly address from any client. And let me show you how this looks in code. I'm going to use I'm going to use a service called weather forecast. Okay, too many windows. Close this. Which using open source, open API, open method that allows you to retrieve the weather forecast by latitude and longitude. So it takes as an input the latitude and longitude, and it calls this service and it provides a response. So it's just Java code. This is how the Spring AI you're going to register your tools, and that's what we're having. And this is the description: get the temperature in Celsius for specific locations. So this is the tools. Then we can convert this. Again, it's up to you. You can auto-wire this, and you can decide what part of this of these tools you would like to expose as a tools in your MCP server. Here, it's very straightforward. Everything that this class provides are going to be exposed as a tools. And with all these things and the magic auto configurations that you have here, saying that this is going to be MCP server, you can run this application and it is going to behave and expose the HTTP SSC protocol. And furthermore, you actually can wrap it, and you can even run this jar as a standard I/O protocol over standard I/O resource. Let's first see how it looks if I run it as a HTTP server. Now it's running, and I have very simple tests that are using the JDK API, practically provided transport. I'm using the JDK, create a client, initialize the client, do the ping, then here I can list what are the tools that are provided by this server. And I can code, in this case, I know what I'm calling this particular tool for the server. So in the case of the standard, the HTTP, I'm going to use this transport to connect to, actually connecting to the local host HTTP 8080. Let's run this bit. Yeah, it connected, it get the information, it listed the service, and it actually have the auto response as well. We can do very same thing for the local response. So this is how this would look if we're using standard I/O response locally. I'm actually pointing to the jar that was generated. This is the Spring Boot application. The jar, it's here. And I can run, in this case, I'm going to use the standard I/O. It's the same application, but it's going to be connected and run. So let's run it for, okay. That's fine, it is there, just, Okay, and what we're going to do now, some little bit more exciting. Let's reuse the same jar and try to plug it into a cloud desktop. Yeah, so, which is cloud desktop. How many of you have used cloud desktop or any of the other cursor or stuff like this? So this is, okay, so for those who haven't used it, yeah, if you have used Google chat, GPT chat, chat GPT or Anthropic chats, this is practically a chatbot that allows you to interact with the stuff. So in this case, you can install it as an application, and you can ask it random things. Practically, it's using the Sonnet, the Cloud Sonnet model underneath. What we're going to do, make additionally, we're going to add additional service developers. So this is how, and this varies for the different applications. Okay, open with. The configuration looks similar, so practically I'm pointing to the jar file that I have just, I can verify that it's the same, copy. And it's running simply application. I could have compiled this into Grow into native application, and actually it would be a little bit more efficient. In this case, I'm actually running a Java. I'm saying that it needs to be a standard I/O. Cloud Desktop supports only standard I/O. It doesn't support the remote content. But if I have used, for example, the C-line protocol, this is another kind of client. I can actually configure here MCP, and I can actually make it talk over, okay, over HTTP as well. So let's see how this works. Save. Restart the cloud. And here you can see that actually it already knows about our get temperatures function that we had in our application. That's what we exposed as a name. Furthermore, yeah, it recognized the jar file that is underneath, and now we can try to use it. Okay, in order to answer these questions, the model actually opted for the server, this tool. It found that, can I move this? Actually, that there is a tool. It's our get temperature tool, but it's asking us if it can perform this execution, Spring AI, MCP weather. We can allow it, and now it is complete the request, so it is 20 temperature, really? I mean, good day in Amsterdam. Yeah, I'm lucky, but we're inside, I'm sorry. And yeah, very long recommendation, what should I wear? I'm not sure I want to follow this. But you see this, the option. We did the two exercises. We actually used Spring AI as a client to talk to some random third-party MCP servers. And we did the opposite. We actually exposed our implementation MCP servers and connected it to the random third-party API. And this is the power of MCP under the hood. It's this interoperable protocol. Yeah, question?
Is it possible to have a part of MCP in one application and a part in another application?
As you can see, the MCP components, the question is whether we can have the part of MCP in one or another application. I'm not very sure what that means because the building blocks are the client and server. So usually the servers, MCP servers, are built by service provider. You as an AI application builder, you are not concerned how those are built. You just consume them, unless you are the service provider that builds the MCP servers. And also, usually you're building a MCP server per particular resource. Okay, this is a very interesting point. There is a criticism, why should I use REST instead of, why should I use yet another protocol? I've heard these bits as well. I think it's very different level of granularity. MCP is really, as a protocol, is high level. It has this high level concept of tools, resources, prompts, and it is meant, so it's meant to provide and serve those bits. So you should, if you try to expose your existing service API, REST API as an MCP server, you're doing something very wrong. So that's not the purpose of the MCP in general. Usually you would have some high-level abstraction that you build that using these low-level APIs, REST APIs, in order to provide some valuable tools or capabilities, but it's not meant to provide these low-level raw APIs to let so people are trying to do these things practically to let the client do a lot of the coding. I mean, for me, this is more the hacking, but conceptually, it's not meant to be to solve this problem. It's kind of, and that means that your MCP server, when you're building for purpose, certain set of tools, and usually you isolate this server implementation from these particular tools. Single server, when it's run remotely, actually can serve multiple clients. And the idea is that you can compose multiple. So you see that the moment in order to talk with particular server, you have to have a client, multiple instances. This is kind of thing that I believe is going to evolve. I don't see why. One of the idea behind is to keep isolation between those communications, but I think you can do it still pretty reliably with a single client talking with multiple servers as well. So I believe this would evolve over the time. But the composition, yeah, you can aggregate in this level. You can build server clients, and then you can decide what talks and connects and stuff like this. So maybe I would see servers, MCP server that talks wraps other MCP servers. Why not? And actually, there is such type of aggregators, yeah, which expose all the bits. How useful is this? I don't know. But yeah, I can see the rationality of this if you have too many services and you want to provide a single MCP connection to talk with them. So rather than spawn multiple MCP clients with multiple servers, you may want to decide on the server side to have a single server that wraps all those and have a single client to talk with and have access to the tools under the hood. Okay, I have 4 minutes, and let's see how we're going with the presentation. I'll skip. So we have the same interaction for resources. This is the kind of resources special type of entity. We can think of it like the files that you are touching your ChatGPT session. So it's something that you as an application developer would use. It's not something like the tools that the model is using. Similar for the prompt. Sampling, I don't have much time to do, and anyway, it's very involving, but if someone is interested, I can show indeed. I have actually an example how this looks like. Can I zoom this? Not really. Maybe I can. Anyway, this is how sampling works. Again, sampling was to let the server talk to via MCP client with the LLM. So imagine that you have the request that is using a tool on the server side. Okay, aggregate some data, retrieve some data, and structure it in certain way. In order to structure the data, the server is going to ask after it retrieves it from some database, let's say, ask the client, can you please structure this data for me using the LLM? And you can actually have a fins, use Anthropic, use OpenAI, use Vertex, so there is different parameters, some metadata. The client would going to delegate, try to figure out what LLMs it supports, delegates the code to this LLM with this data and return the response, and then the server it responds. So I think it makes sense. It's a little bit involving back and forth, piggybacking situation, but it's powerful. So the Java SDK itself supports sync and async API. I forgot to create a snapshot like this morning, but if you go to the specification, this is the model context protocol, go to the SDK, client, and for any snippets you can see you have a sync and async access to it. It's up to you to decide which one you want to use. Are there many reactive programmers here, or? Okay, few, which is very common. Authorization, the new specification that was released on 26th of March actually come with authorization capabilities. It's based on OAuth 2.1, and Daniel Garnier already actually yesterday published a blog about 2nd of April, indeed, about how you can actually secure with the Spring integration. So it is work in progress. There is some criticism in general. I advise you to read the blog, and there is a related example, actually, that's using the very similar MCP weather example, I believe, under the hood to secure it with OAuth. The most significant criticism I'm seeing, I've heard about this specification, this approach so far, is that right now the specification demands that the MCP server play the roles of OAuth server and authorization server as well. So the guy, which is kind of usually those two roles are dedicated. Normally, you would have the MCP server play the role of the resource server from the standpoint of OAuth, and you would have some centralized instance that is going to provide you with the tokens and stuff like this. So this most likely would involve. And I was about to discuss the agentic system, and yeah, this is, but now we are running out of time, I believe. So I would advise you to read this very influential paper by Building Efficient Agents that comes with the idea of common agentic patterns, and it grades them on the scale of how much they are prescriptive workflows versus more autonomous agents where you delegate to the agent to do the actual breaking of the work into separate steps. For example, the most simple one, the chain workflows, you as a human may decide what are the LLM's actions that you would like to be performed in order to solve some certain task, and then the output one is chained to the next one in order to solve the problem. If you want to have a little bit more autonomous solutions, then you have something called orchestrations, where actually you have this applies for use cases where you cannot upfront decide what are the tasks that are involved in the processing. In this case, you are going to delegate to dedicated LLM or planner to decide how to plan this and then execute these bits under the hit. So I have, for this, I have implementation and blog post for how to use this with Spring AI. All these bits, you can do it. What is more interesting is that recently I discovered this MCP agent framework, which actually under hood implements those patterns and is using the MCP as a connection to interact with its environment. And of course, I went ahead and implemented some part. I just started this week on this. I'm going to continue this work on the Spring AI community site as a community project. It looks very interesting, and yeah, I already implemented the registration part. It is available there. I don't have time to show it now, but it is quite interesting and scary how it works. I had to back the model not to create too many tasks and too many steps because my Anthropic account really dropped and yeah. So, and thank you very much for the attention. I appreciate it.